Hello everyone, welcome back to the channel. I hope you're all doing great. If you've been following along with our previous videos, you already know that we've talked a lot about algebraic identities. We've covered what they are, and we've even solved quite a few examples together. But here's the thing, practice makes perfect, right? So in today's video, I wanna take things one step further. I'm going to solve some more important and challenging examples for you. These examples will really help you understand the deep stuff and get you ready for any kind of problem you might face. Trust me, by the end of this session, you'll feel much more confident. But before we jump into the examples, I have a small request. If these videos have been helpful to you so far, please show some love and hit that like button. It really helped me make more content for you. And if you haven't joined this family yet, make sure to click on subscribe right now so you don't miss the next lessons. Alright, enough talking. Let's get started with our first challenging example. Suppose that x plus 1 over x is equal 5 is true. In that case, what would be the result of x squared plus 1 over x squared? Now, the first thing I notice here is that I see a square. I have x squared plus 1 over x squared. And whenever I see a squared, the first thing that should come to my mind is our very first identity. It means a plus b whole squared is equal a squared plus 2ab plus b squared, or a minus b whole squared is equal a squared minus 2ab plus b squared. You can use both identities, whichever one is needed. So since we have a squared plus b squared, so since we have x squared plus 1 over x squared, I am thinking, what if I square this expression? Maybe that will help us get closer to what we're looking for. Let's try it and see what happens. X plus 1 over x is equal 5. So if I square both sides is x plus 1 over x whole squared is equal 25. So x squared plus 2x times 1 over x plus 1 over x squared is equal 25. And since x times 1 over x is just 1, so the middle term becomes 2. Okay? So we get x squared plus 2 plus 1 over the x squared is equal 25. So x squared plus 1 over x squared is equal 25 minus 2 is equal 23. Let's go to another example. Suppose that x plus 1 over the x is equal a is true. In that case, what would be the result of x cubed plus 1 over the x cubed? Whenever I see a cube, the first thing that should come to my mind is our cube identity. It means a plus b whole cubed is equal a cubed plus b cubed plus 3ab times a plus b. So based on this expression, x plus 1 over the x whole cubed is equal a cubed. So x squared plus 1 over x cubed plus 3x times 1 over x times x plus 1 over x is equal a cubed. So x times 1 over the x is just 1, and so we have x cubed plus 1 over x cubed plus 3x plus 1 over x is equal a cubed. X plus 1 over x based on this expression is equal a. So we get 3a. So x cubed plus 1 over x cubed is equal a cubed minus 3a, because x plus 1 over x is equal a. Number 3. We know that a plus b whole cubed is equal a cubed plus b cubed plus 3ab times a plus b, and a minus b whole cubed is equal a cubed plus minus b cubed minus 3ab times a minus b. Okay, of course we'll be using this identity because I suppose 2 minus root of 3 is equal a, and 2 plus root of 3 is b. So a cubed plus b cubed, a cubed plus b cubed. So we have a cubed plus b cubed is equal a plus b whole cubed minus 3ab times a plus b. So 2 minus root of 3 whole cubed plus 2 plus root of 3 whole cubed is equal 2 minus root of 3 plus 2 plus root of 3 based on these identities whole cubed minus 3 2 minus 3 root of 3 times b, 2 plus root of 3 times a plus b, 2 minus root of 3 plus 2 plus root of 3. Okay, so we have 2 minus root of 3 whole cubed plus 2 plus root of 3 whole cubed is equal minus root of 3 plus root of 3 is cancelled, and 2 plus 2 is 4, cubed is equal 64. Okay, minus 2 minus root of 3 times 2 plus root of 3 is conjugate identities. So we have 3 times 4, 2 squared minus root of 3 squared is minus 3. Okay, times, in this expression, minus root of 3 plus root of 3 is cancelled, and we have 4. Okay, so we get 64 minus, here is just 1, and 3 times 4 is 12. So 64 minus 12 is equal 52. So 2 minus root of 3 whole cubed plus 2 plus root of 3 whole cubed is equal 52. Now you can write